This is a lesson on solids. There are 5 different categories of solids according to the book. Solids retain their shape, is the old classical thing. Most of them also have a repeating pattern of some sort. First solid we're going to talk about is metallic solids. Metallic solids have the inner parts of the atom, that's the nucleus, and the inner shell electrons in a pattern. The valence electrons are free to zip around wherever they want to. This explains why metals conduct electricity, because electrons are free to move around. There's a bonding molecular orbital theory that explains that they're shared by all, and that's in your book if you wish. It's the pattern, the theory that's everybody's on to now. Regardless of whichever way it is, it's a delocalized electrons. So molecular orbitals or just saying electrons are free to wander around, both explain it. If you have a mixture of more than one type of metal, you have an alloy, which is a mixture. They can vary in percentages. You can have a alloy where you have interspatial, where the atom, the additional metal takes a place in between the atoms, or replacement, which means it can take the place of an atom. So you can either fit it in the holes or you can replace one with another, both of which are alloys. Next is network atomic. Network atomic, an example of this would be like diamonds, where you have all the atoms are connected with covalent bonds. So all atoms are connected to each other with covalent bonds. Essentially, these are one giant molecule. They're not separate. So every carbon atom in a diamond is connected to every other carbon atom in that. Sometimes you call it like a supermolecule. These are especially hard most of the time compared to what they have. So I like calling them supermolecules. The entire crystal is one giant connected thing. Examples: graphite, diamond, quartz, silicon dioxide, quartz, sand, they're all the same. There's 2 types of these. You've got the true solid, which we mentioned last lesson. True solids have a set repeating pattern of atoms, also known as cells. And these have a set melting point. They melt at a specific temperature. That's a true solid, because all the bonds break at the same energy. You can have an amorphous solid. An amorphous solid, the pattern is not as set. There are major irregularities. There are major irregularities. It's an irregular pattern. You do not have a set melting point. A couple of examples of this would be like butter. As you warm up butter, it gets smooshier and smooshier. It's not solid at one point, liquid at another point like ice. Another example would be glass. Glass is specifically a network atomic solid that, because this butter is an organic compound, but it still illustrates it. Molecular solids. Molecular solids. Molecular solids are molecules where molecules take the place of the atoms. Molecules in a set pattern. They're connected by the three forces, the LDF, the weakest. You can have DD, dipole, or HB, hydrogen bonding. So they're molecules that, this is like ice or dry ice or other compounds like that. And the third type is ionic solids. Ionic solids, instead of molecules or atoms, they have ions in the set pattern. Sodium chloride, example of that. What you should really know for the test, hint, 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 is this table. There are 5 types. I talked about 4, but the noble gas is kind of a special subset. So the type, you have the network atomic, you have the metallic, you have the noble gases or group 8A. I would prefer group 18. I like the European version. Molecular solids and ionic solids. This table is in your book. What is the unit? What is being connected? Network, metallic, and group 8A are repeating a series of atoms. Molecular is molecules, and ionic is ions. That's not too difficult. The type of bond that holds the solid together. This is called directional covalent, or I just say covalent. Covalent bonds. The type of bonds here, this is non-directional. Covalent bonds means they're sharing electrons with 2 different atoms. So that's directional. Metallic is sharing atoms, sharing electrons, but they're sharing it with all. So this is the sea of electrons, where the electrons roam. So here the electrons are shared by 2, here the electrons are shared by all. LDF is the only type of option for the noble gases, group 8A. Molecular solids can be any of HB, BD, LDF. And remember, if you have HB, you have all 3. If you have BD, you have those 2. All 3 are present if you have hydrogen bonding. Dipole, and London dispersion forces are present if you have dipole bonding. It's a polar molecule. the type of bond in ionic is ionic. An example, the strongest overall, now these are general guidelines, the strongest overall is the network atomic, followed by ionic, and this is determined by their melting points. Highest melting point down lower. And there is overlap, but this is like an average of them all. Definitely group 8A is the weakest. They're gases at room temperature and much below room temperature. This is where it kind of gets wishy-washy. Metallic overall might be 3, and molecular might be 4. 4 is probably pretty good. 3 and 2, some ionic, some metallic, they might switch places. But overall, ionic compounds as a group would have an average melting point than metallic. If you want to do specific examples, that's not going to work. So there are many exceptions. But we can talk in broad categories on this. So that concludes this lesson on solvents.